Geometry students, we have one more unit until the end of the year, and I don't know if we'll have a test on this unit. I think this stuff will just appear on your final exam. It's one of my favorite units in all of geometry, and it has everything to do with circles. So let's do a little review. Hopefully you know that a circle is a set of points in a plane that are equidistant from a given point, and that point's called the center. When we have a circle with a center, we write it this way, circle with center P, and that tells you the point that is the center. A segment whose endpoints are on a segment whose endpoints are the center and any point on the circle is called a radius. You know that. That's the red segment here. A chord is a segment whose endpoints are on the circle. So the diameter is a chord. The diameter is a chord that also contains the center. But musicians don't think that the chords of music are not related to that word chord right there for a segment that hits endpoints of a circle. You can think of guitar strings that go across that circle in the guitar's bass. Also with circles, a couple lines that you might want to know about. A secant is a line that contains a chord. It's a line that hits the circle in two places. A tangent's a line that hits a circle in exactly one place, and that point where it hits is called a point of tangency, and then it goes on to say a tangent ray is part of the tangent line. There's also a tangent segment. So when we say the word tangent, we talk about rays, segments, or lines. Good to know those vocab terms. So other things to know with circles, you can, when we talk about coplanar circles, we can have circles with 2 points of intersection or 1 point of intersection. Notice these are called tangent circles. There's a tangent line here and there's a tangent line here that shares that red point of tangency. Then there's circles with no intersection points because they don't overlap at all, or they're concentric circles. Breaking down using your Latin, con means with, centric obviously meaning with centers, so same centers there. Other things about common tangents, circles that have the same tangent line here or circles that have the same tangent line here. A lot of times these are called externally tangent versus internally tangent, but I'm not too worried about that. But the fun thing about tangents are these theorems. In a plane, a line is tangent to a circle if and only if it is perpendicular to the radius of the circle at its endpoint on the circle, or at the point of tangency. Interesting proof. You actually have to prove it both ways because it's an if and only if, and it's a proof by contradiction. You assume it's not perpendicular, and when you assume it's not perpendicular, you get yourself into a contradiction of something we know to be true. So you can prove that this is a right angle. And then what ends up happening is you get all sorts of cool right triangle problems when we have this right angle in here. Another theorem for this unit is if you have if you have tangent segments from a common external point, you can prove that those two segments are congruent. I'll walk you through the proof right now. Draw a radius here, we know it's a right angle. Draw a radius here, we know it's a right angle. Connect the center with this external point. You know the hypotenuse is congruent to itself. You know any two radii are congruent, so the legs are congruent. And then by hypotenuse leg, you have congruent triangles. So we know that the external segments would also be congruent. One of the big mistakes kids will make in this chapter is accounting for that radius. So let's take a look at a practice problem. All right, so the biggest mistake we make is we'll draw this circle. We've got the center. I draw a tangent line there, and I give you the problem, and it looks like this. I tell you the tangent segment from the point of tangency to this point is 12. And then I want you to find, I'll give you some more information. You'll need more than that. I'll also tell you the length of the segment from here to here is 8. And I want you to find the radius of the circle. So when we start drawing the radius of the circle, and here's radius, I know it's perpendicular. Don't forget that this is also a radius from here to here. And when we go to do the algebra, here's where we make our mistake. A lot of kids will say r squared plus 12 squared equals r plus 8 squared. And then they'll say r squared plus 144 equals r squared plus 64. And the mistake you've made is an Algebra 1 mistake. When you take r plus 8 and you square it, you're multiplying by another r plus 8. That's r squared plus 8r plus 8r plus 64. That's r squared plus 16r plus 64. So you have to have that middle term in there when you square a binomial. Please be careful with that, algebra students. When we solve for r here, I end up getting 144 minus 64. What is that? 80. 80 equals 16r because the r squareds cancel. They're on both sides. Divide by 16. I think when I divide by 16, I end up getting 10 over 2 or 5. So this is a 5 and then this is a 5. And there was actually an easier way to do this. 5 plus 8 is 13. So I was trying to build in a little triple there to make the math easy for me. But just be careful with your algebra. Good? All right, lots of practice problems on Monday. This is our last unit. Like I said, probably just on the final, and there won't be a test. All right, peace.